Hello, Prealgebra students. This is lesson 35. Our objective is how do you tell if polygons are similar, congruent, or neither. So let's just go ahead and talk about the definition of similar polygons and congruent polygons. Similar polygons have corresponding angles which are the same measure and corresponding sides which are proportional in length. Proportional means is like 1/2 is equal to 2/4, right? That would be proportional to each other. Congruent polygons have corresponding angles which are the same measure and corresponding sides which are the same length. So kind of in short, similar means same shape but doesn't have to be the same size. Could be, but doesn't have to be. And then congruent means same shape and same size. So this is example 1. It says, which two quadrilaterals are similar? So think about here, I'm looking for two that are the same shape, but maybe different sizes. So I'm looking through here, and I'll notice A has 180, 180. Same with B and same with C, but notice D is a different pattern. It goes 100, 180, 80. So, and even if you look at it, this is not the same shape as this. So I'm going to go with not D. D is not going to be in there. So it's going to be A and B, A and C, or B and C. So what we need to do, since those are kind of the similar shape, we need to see which sides are proportional to each other. So let's try A and B and see if that works. A and B, let's see, so that would be, let's go short side of the shorter one, 6, over short side of the bigger one, 8. And C, is that equal to long side of the shorter one over long side of the bigger one? It's kind of short over short, long over long. Well, if we reduce those, 6 over 8, 2 goes into both those, it's 3/4. Is that equal to, well, 4 goes into both of those, 4 goes into 8 2 times, 4 goes into that 3 times. Is 3/4 the same thing as 2/3? Well, no, those are not equal. So maybe let's try A and C. So let's see. Do the same thing, short side over short side, so it's going to be 4 over 8. Is that equal to long side over long side? 6 over 12. Reducing the left hand side, 4 goes into the top one, bottom one twice. Is that equal to 6 goes in the top one once and the bottom one twice? So is 1/2 equal to 1/2? Well, yes it is, so it appears that A and C will be proportional. We could do something similar here with B and C. That's our only other option. See if those two are the same. We could say short would be 4 over 6. Is that equal to 6 over 8? Reducing both of those, 2, and that 3 times. 2 goes into that 3 times and into that 4 times. So again, no to that one. So then my answer is going to be A and C are similar. Okay, now a couple ways to, when we're talking about triangles, is to see if they're similar is by side, side, side. There's a theorem that says if two triangles have proportional corresponding side lengths, then the triangles are similar. So if the side lengths are proportional, all three, then those triangles are similar. We don't have to worry about trying to figure out the angles. And also, we have an angle similarity. It says if angles of one triangle are congruent to the angles of another triangle, then the triangles are similar and their corresponding side lengths are proportional. So now we're just trying to see for A and B, are the triangles similar? We're going to say yes, they're similar, or not, or no, they're not similar. So let's look here at part A. I have a 60, a 70, and a 50. And the second one also has a 60, a 70, and a 50. So then by this angle similarity, I could say that these two are similar. So what we're going to do is I'm going to say ABC, triangle ABC, is similar. That's what the little squiggly symbol means. Triangle, now notice I said 60, 70, 50. So I'm going to go in that same order over here. 60, which is the Z, Y is the 70, X. So notice ABC is similar to ZYX. If I had said XYZ, that would be a false statement because A corresponds to Z. See, those are both 60 degrees. B corresponds to 70 to Y because they're both 70 degrees, and X corresponds to C because those are both 50 degrees. So that's why whichever order I pick here, I have to follow the same proper order for there. So this would be my answer here. So I'm saying that those two are similar. So let's try this next one, part B, and see if these are proportional. So it looks like my longest side is going to be 7 and 4. And then my shortest side is going to be 5 and 2.5. And then my middle side is a 6 and 3. So we just want to see if all these proportions are the same. So let's just go ahead and start with the shortest side. So I'm just going to go with smaller over larger. So what I'm wondering is 2.5 over 5. Is this the same thing as, let's go with the middle one, 3 over 6. Well, 2.5 goes into 5 2 times, so this is going to be 1 over 2. Is that equal to 3 goes into 3 1 time, into 6 2 times? So yes, so far so good. It seems like those are going to be proportional, and I would say yes, that they're similar. However, notice whenever you use the longest sides, is this the same thing as 4 over 7? Well, no, not quite. Right? If it was 3.5 over 7 or 4 over 8, then that would work. But this is not equal. This one is not. So that means these triangles are not similar. Okay, so let's look at example 2. So the triangles are similar. Find the value of x. There's actually two different ways that we can go about solving this. One way is to set up a proportion. Since I'm looking for this x, I'm going to say x over the corresponding side over here is 3. So I'm going to say x over 3 is equal to, well, I can pick either 15 over 5 or 12 over 4. Doesn't necessarily matter. I'm going to go with the 15 over 5 because I like working with 5s. So I'm going to say 15 over 5. We will cross multiply. So I end up with 5x is equal to 45. Dividing by 5s, I get x is equal to 9. Alright, so that's my answer. There's x equal to 9. But there is another way to do this as well, and this is using a scale factor. A scale factor means a number that I would multiply by. So think about 4 times what is going to give me 12? Well, 4 times 3 gives me 12. And notice 5 times 3 gives me 15. So my scale factor is equal to 3. Because I can take the number from here, multiply it by 3, and get me the number there. So if I follow that same principle, I can say 3 times 3 It's going to give me that one. So that means x is equal to 9. Okay, so either way, notice we got the same answer. You can pick your method most of the time, but here in example 3, we're actually going to need to use our scale factor. Okay. It says an architect makes a scale drawing of a building. If 1 inch on the drawing represents 4 feet, then what is the scale factor from the drawing to the building? So if I have 1, what would I have to multiply by to get 4? So my scale factor would be 4. So part A, I would say scale factor is equal to 4. B, it says, what is the length and width of a room that is 5 inches by 4 inches on the drawing? So let's kind of just take a quick look at this. This is for part B. I have something that's 5 inches by 4 inches. 4 inches, 5 inches. So in real life, it's going to be bigger than that. I'm just trying to find these lengths. Well, since I don't have one of the lengths, I can't really use my first way of setting up a proportion. However, I do have a scale factor. I know that if I multiply one of these lengths, or either of these lengths by 4, I should get the length over here. So what we're going to do is we're going to multiply this by 4 and multiply this one by 4. This will give me this new side, so 5 times 4 is going to give me 20, and of course my new measurement is in feet, 20 feet, and